This Haier PCB is completely dead, and here you can see that its operational amplifier, this is IC9, has completely blasted. Look, there is a hole inside it. Similarly, some resistances around it. Look at these. These are also finished. Along with this one is also burnt, this one is also burnt, and some resistances are also burnt. So this whole circuit is the power supply current sensing circuit. And similarly, whenever high electric fluctuation usually comes in this PCB, its IGBT also gets short-circuited. And this circuit also blasts along with it. First, we will test this. Then after that, I will tell you what other thing shorts in it. So we will set the multimeter to diode mode. And look, when we put the probe on its IGBT, look, it has completely become 0. This one is also 0, so it is completely shorted. Similarly, if we check this diode, these two outside pins are common. They are attached at one place. So look, it is showing 0, while the inner one is its cathode. So here its position is completely okay. This is totally fine. Whatever things are physically damaged, we will remove them from here first, because after that when we test, the remaining things will show us their position. Now, before repairing the PCB, there is always a physical test. So look, it did not pass in the physical test, because these things are physically visible to me that they are damaged here. So I will remove them from here first. After that, if I need to check anything else, I will check those. So I will directly cut the IGBT from here. For now, I will not remove it. Similarly, this plastic also has to be removed from here. So I will cut this from here as well. So look, this will have to be lifted, and this will also have to be lifted. Actually, I cut this in the wrong place. It should have been cut from here, and from here. Look, it has completely come out. Now, the thing I was talking about, that this also often burns, this is its shunt resistance, which is 5 watts, R015. This resistance is approximately 15 milliohms, so this also gets short-circuited, meaning it burns and gets disconnected. I will show you. Look, let's check it. When I connect it here, look, put it on continuity mode or resistance mode. In both modes, if you check it, it will not show any value. Look, no value is showing here. This means it has completely burnt. Now first, we will remove all the burnt components from here. Now this resistance, look, it has completely burst here. And as I showed you, this is a 5 watt, 15 milliohm resistance. This IC here is a 2772Q IC. This is an operational amplifier. The remaining resistances I have removed from here. Now we will clean it properly. We will clean all the points properly so that the new parts, whatever things we have to install here, can be installed properly. One more resistance has come out. We will install all of these new. So here, let's check this resistance, R64. This is a 1 kiloohm resistance. I will check it. So this is showing 1 kiloohm, okay. So here, look, these two resistances installed here, R63 and R68, both are 9.1 kiloohm resistances. So we will check them. And I think these are connected in parallel, so their value will show half. Yes, these two are connected in parallel, so we will check them. So it is showing 1 kiloohm here. So in the circuit, often it can happen. It is possible that, look, 9.10 kiloohms, so this is showing completely okay, while this one, its value is showing low, 0.967, so its value is low. That is why we will remove it from here, because whatever thing is faulty, we will not leave it here. And if this resistance is checked here, 80820, then its value is showing 76 ohms. This is exactly an 82 ohm resistance, 820. And this R65 is a 10 ohm resistance. Let's check this as well. So look, its value is showing 9.9 ohms, so this is completely fine. Along with this, O1B, so these are also 11 kiloohm resistances. Let's check them. 1 kiloohm completely okay. This R59 beside it, so this is showing value in ohms. This is also 1 kiloohm, and beside it, the one is 10 kiloohms, so it is showing 6 ohms. And there is a capacitor installed with it, C21, so their value is showing low. Now we will check this capacitor as well, in continuity mode. So here, I think there will be a beep. definitely there will be a beep, because here their value is showing low, and this is in parallel with it. So I will remove this capacitor and this resistance from here, because these are doubtful. It is very important to clean all the points properly. If its cleaning is not good, then our soldering will not be good. When the soldering is not good, then the work will not finish quickly, and sometimes it is not correct either. So that is why cleaning them is very important. Once we clean them, then soldering becomes easy after that. Now, the next point we have to check in this is that there should not be any further short circuit here. If there is a short circuit, then this is a problem. So for this, we can use two methods. One method is on continuity mode, and one is on diode mode. So we can check on both. First, we will check on continuity mode. So look, our meter is completely okay. Now here, this IC, it's pin number 4. We will take it here. Here is ground, and this pin number 8. Here is the positive point. So here is VCC. 5 volts come here. So let's check it. Here, it is giving a beep sound. Now let's check it in diode mode as well, because voltage drop should come here. It should not be 0. So this point is 0, meaning there is still another problem in it. Before installing components here, we will solve the short circuit problem. Then after that, we will do further work. Now we will check this short circuit on this microcontroller to see whether this microcontroller is short or not, because if this also becomes short, then it is also a problem. 2 supplies are given to this microcontroller, then it operates. If even one supply does not work in it, then the microcontroller will still not work properly. So the first supply is here, on its pin number 8 and 10. Here, look, on 8 and 10, this capacitor is installed, whose number is 38. So we will check capacitor number 38, and there should not be any kind of short circuit here. So we will check on continuity mode. When I put it here, look, the multimeter keeps beeping, meaning a short circuit is present here as well. Apart from this, the second supply comes here, number 42 and number 44. So, on number 44, look, these 2 pins are connected with each other. Pin number 44 and 43 are connected with ground, and look, 41 and 42 are joined together. 41 and 42 are connected with each other on the positive side. So we will check here, meaning with this C36 capacitor. So we will check here whether there is any kind of short circuit here or not. So we put it here and put the second pin here. So this is also short circuit. A short circuit is present in both supplies. Now, this is not our final decision here that the microcontroller has shorted. Why? Because look, all these capacitors installed here should also be short-circuited, grounded from the positive side of the microcontroller. So I will check the remaining capacitors. Look, I checked this one, there's no beep of any kind. After this one, there's no beep. Then on the next one, no beep. Then on the next one, no beep. This one, look, here a very slight reading is coming. Look, there's no beep, but it's showing voltage. Oh sorry, here it's showing ohms value. A value of 225 ohms is showing along with it. But with the rest of the capacitors, its value is not showing. Now here, we also have to check 15 voltage, that these 15 voltage are not short-circuited with ground. Apart from this, here is the IPM. I have checked it. It is completely proper. I have checked its bridge rectifier. So the bridge rectifier is also okay. I already showed you that the diode is also okay. Now we come to the SMPS. If any component near the SMPS has also become short-circuited, then it will still show all these things short here, because it has to make 5 volts. So let's see if there's a short circuit right from the startup here, then a component here can also be faulty. And often, these snubber diodes, etc., become open or short-circuited, so we will check them here. So here, look, one diode is installed here, and the second diode is installed here. This diode number, look, this is 21, this diode, and this diode here, I think this is 23. So let's check 21 first. When I checked it, look, no matter which polarity we connect, there's no problem. So here we are not getting a short circuit. Now what I do is change the probe polarity and check again. So here we are getting 0.3889 voltage drop, meaning there's a chance that this snubber diode is fine. Now we come to its diode number 23. The one we checked before, diode 21, is for 15 voltage while diode 23 is for 5 volts. So look, Here, the snubber diode is also short-circuited because there is no voltage regulator here. From this chopper or transformer, the 5 volts are directly made stable, and all the functions are happening in forward bias. This is also showing short circuit in forward bias. Now I will test it in diode mode. So look, the snubber diode is completely okay. This is completely okay. There is no issue in it. And now let's see whether this short circuit is still present in it or not. Now we will check the capacitor again in continuity mode. So yes, it is still short. This is still short-circuited. Now what is the solution for this? The solution is that we leave all the work and check this microcontroller. Okay, we will check it, then everything will become completely clear. Okay, here I will tell you one more thing. When we check this capacitor here, normally if you check it in continuity mode, even then you will see the buzzer here. Okay, look, this is showing 0 and it is completely direct, and 1.5 ohms are showing. But if the buzzer comes here and its value, I will show you if someone else does it like this. Look at this capacitor. Look, here it is showing a value of 223.9 ohms, so this means it is not short-circuited, okay? And then if we check this same capacitor here in diode mode, which is showing ohms on the buzzer, then I will show you. Look, this will show voltage drop, 0.231 voltage drop. If this kind of situation appears, then it will be completely okay. So look, this is 0. If here on buzzer, it had shown 200 or 300 ohms value, and in diode mode, it had shown voltage drop, then it would have been completely okay. Then there would have been no problem in it. But because now it has become direct here, this microcontroller has shorted internally. Look, it will have to be removed. Now look, first we will do it in continuity mode. Check the probe, it is okay. Now look, this capacitor place, the capacitor has been removed from here. We will check these. Now look, 172 ohms value is showing here, and when we take it to diode mode, voltage drop should come here. So 1823 voltage drop is coming. So the work has improved somewhat, only and only by removing this microcontroller. This is now in this position. And now let's check its capacitor, this one as well. So voltage drop should come in this. So look, 0.182 voltage drop is coming. Okay, on continuity mode, value should come in ohms. So look, 172.9 ohms. Now at the end, we will check whether this microcontroller is really faulty or not. So let's check it. 1, 2, 3, 4, 5, 6, 7. And this is pin number 8. We will connect with this, and with number 10. So look, these two pins are short with each other. Look, the microcontroller has totally shorted internally. Now I have no solution for this because I do not have another microcontroller. So this PCB will now go into non-repairable.
Click on the left or right thumbnail to watch our next videos. And subscribe. Thank you.